Okay, Bismillahirrahmanirrahim. Welcome back. So let's move to part 3, the application of the piezoelectric. So what are the examples of the piezoelectric device? So there are two parts. One is the actuator, another one is a micro sensor. So we're talking about MEMS, right? So it will be a very small device, micro. So inside your micro actuator for the piezoelectric, one of the famous example is the printhead ink droplet ejectors. That is the printhead. Another one is for the micro sensor. The most popular one is the accelerometer, and there are another part here that is surface acoustic wave devices. So when we talking about the MEMS micro actuator and the micro sensors, there are three parameters that we need to take into account. One is the speed, another one is the dynamic range, and the sensitivity. So if you recall the last week video, so what is the sensitivity? So let's say this is it will be calculated by the gradient, right? So y over x depends what is the input and what is the output. So these are three parameters that we are going to look into when we design the micro actuator and the micro sensor. So when talking about the actuator, the performance is the displacement and the frequency response, and same with the sensor is the sensitivity is the most important, and the repeatability and the frequency response. So if you look this figure for the piezo MEMS device, after this we're going to learn about the fabrication techniques. One is the additive approach, that is what we call surface micromachining. Another one is what we call subtractive approach, that is called bulk micromachining. And some of the devices they have a hybrid approach where it consists of both for surface and the bulk. So both of these fabrication methods will determine the performance of the micro actuator or micro sensor. So for the actuator, example is the inkjet printhead, and we have the optical mirror. For the piezo sensor, some of the example is the accelerometer or gyro sensor. Gyro, we measure the rotation angle, and some of the important application is the energy harvester. So what is energy harvester? It will, when you vibrate some of the piezo material, it will accumulate the charge. So this voltage, we call it harvest the voltage. It give the energy, right? So in some sort, we replace the battery where when you have some piezoelectric material inside your device, it will accumulate the voltage and you don't need the battery to be included in your device. So other than that, we have the saw and bulk acoustic wave. So inside this device also we have piezoelectric material. So ball means there is a bulk here, and saw means surface acoustic wave. Both of this device using the piezoelectric material for it to work. So we'll explain in detail for saw and ball in the next slide. Okay, let's move to the MEMS piezo sensors. When talking about sensors, the output is in terms of the electrical, either voltage or frequency response or charge or the power dissipation. So your input can be from environment, let's say from acceleration, so that's what we call accelerometer, pressure sensor, or the angular rate, or we have a magnetic field, or even the chemical, either this is a liquid a fluid, right? Either it is a liquid or the gas. So in the middle is where the principal play role. So here we are going to focus on the piezoelectric material. So we have two parts. So sensor, always about direct. Direct means what? We are converting from some mechanical input, let's say temperature or acceleration, into the electrical output, that is voltage. So this is what we call direct effect, where we give the word sensors. So on top of that, there is another mechanism for the piezoelectric, what we call acoustic wave. So the wave here is in the form of mechanical. Okay, so how the microsensors works, you have an input signal, so the output will be in terms of voltage, charge or frequency. So inside your sensing element also you have the power supply as a signal processing. Okay, so there are two types of the sensor. The first one is acoustic wave, another one is direct. So what are the difference between these two? Okay, so let's move back here. if we're talking about SAW or QCM, there are two turnaround of the conversion. So let's say, where is the figure just now? So this is the figure of the acoustic wave, right? So let's say on top of here you have electrode. The substrate is your piezoelectric. So what you need to apply here for your acoustic wave is a voltage, either RF signal or some frequency here, RF voltage. Okay, so when you apply the voltage here, since here is a piezo material, so this voltage will change to electrical, right? Voltage electrical will change to mechanical, where there will be some waveform on the piezo substrate. So that's what we call acoustic wave. So if it is SAW, so this will be surface acoustic wave. So at your output, there is some electrode again. When this wave reach the electrode, it will again convert the wave. Wave here is mechanical to the electrical. So for acoustic wave, there are two types of conversion. The first one from electrical to mechanical, and then it convert back to electrical, and you're going to receive some signal here in terms of the frequency or voltage. So there are two types of conversion in the acoustic wave. So you can make this acoustic SAW or QCM is about acoustic wave to become a sensor. Okay. So how about direct effect? So for direct effect is only one type of conversion. So your input will be either mechanical, temperature, change of pressure. So the output will be in terms of voltage, right? Voltage. So let's say the input is acceleration, then your output will be voltage. So it's only one conversion. Okay. Okay. So again, this two is actually the acoustic wave, and this two is the direct effect. So where this piezo energy harvester comes from? So harvester means you are going to vibrate the piezo material, right? When you vibrate it, you're having a mechanical energy, and you're going to accumulate the voltage to become a power source. So that's where it's called piezo energy harvester. So there are various applications of this piezo sensor. One is a mechanical, another is flexible, where you use polymer as the substrate, and the last one is most popular one, that is energy harvesting. Okay, so these are the various application of the piezoelectric MEMS. One's actuator, resonator is what we're talking acoustic wave. So we have here SAW, F bar, and the rest. And we also have textile sensor. So this is the piezoelectric must be flexible. So the piezo must be flexible, so you need to have like polymer piezo, and energy harvesting to replace the battery, so it will convert from vibration to the voltage. And again, here is a flexible where you need to use polymer piezoelectric.